Hey Techno Studs, so let's get into the application layer basics. What we're going to be talking about is what the application layer looks like in the OSI model. Then we're going to take a look at what it looks like in the TCP IP model because it looks a little different and there's a reason for that. Then we're going to take a look at the peer-to-peer versus client-server relationship. Then we'll take a look at application layer protocols. What are some of the protocols that we find within this layer? Then we're going to get into just a high overview of specific protocols that we find within this layer, such as DHCP, DNS, and HTTP and HTTPS. Of course, we'll also take a look at the URL and what a URL does and what it looks like. All right, in this module, I said we're going to be looking at layers 5, 6, and 7, although I also said it's the application layer. And the reason for the discrepancy is that there's two different models out there. There's the older OSI model that a lot of the older protocols will fit into this 3 separate layers, and perhaps one of the layers is the actual setting up the connection between 2 different applications where maybe there's some sort of encryption that's happening at a different layer, and so there's a reason that it's separated out into the session, presentation, and application layers. Although with some of our newer protocols, it really is all combined into one layer. And the reason for that is that we combine all of the let's say the encryption into, it's just incorporated into the protocol at the application layer itself. So for instance, we have HTTP, which operates at layers 5, 6, and 7, or in the OSI model, it's in the application layer. But then when it comes to HTTPS, which is a secure form of that, it once again operates all at those 3 layers, so all at the application layer. So you'll find a lot of your newer protocols that you'll be working with in that TCP IP model. Although if there are some older technologies that you're working with, or something that's a little off from what we're used to dealing with the internet, then you may find some other protocols that fit better into this 3-layer system, or excuse me, not the 3, the 7-layer system, where session, presentation, and application are all broke out separately. So back to the OSI model, what we're looking at is layers 5, 6, and 7. All right, and then we've got several examples here for each one. So 5, 6, and 7 are broken down into session, presentation, and application. And a lot of the protocols that, once again, that we will be working with fall within this layer 7, or in the TCP IP model, actually span across all 3 of these layers right here. As we're looking at it, it really all has to deal with getting the data prepped and ready to go to be sent over. It's transmitting that, so where the applications then are talking between each other. You probably have some sort of client application that's talking to some sort of server application and communicating back and forth. So that's where we are going to be talking about, is that layers 5, 6, and 7 going forward with this module. So one thing to understand is there's a couple different scenarios here with the relationships. So in this example right here, let's talk about peer-to-peer. So peer-to-peer has let's say we have a printer now that's hanging off of this machine right here. And this machine is sharing this printer out, and all other devices are then accessing it. So really, it's still somewhat of a client server in that these machines have some sort of client application that's running on them, and then accessing some sort of server application that's running on this, that's sharing out this printer. So in essence, there's still a client server relationship, except for the difference is when it's peer-to-peer, then that means that these devices are really at the same level. So this device right here is still a client machine. There are still users that are getting onto this machine and utilizing this machine for their day-to-day workload. But they happen to have a printer that's hanging off of it that's sharing out to some of these other devices. And perhaps maybe this device right here on this end is sharing out maybe a shared folder and providing services to these machines right here. So the idea behind this is there's not really a server that's dedicated to sharing out files and folders and printers and that type of thing, but instead that everybody just kind of shares the workload and their user machines, and people just share out resources on those users' machines. So there are peers sharing to other peers, and that's why it's called peer-to-peer. So then there are client-server relationships. Once again, there's client applications that are out there that are trying to get services from a server application that's out there. But there are also the idea behind, we actually set up a server for the purpose of administering different services, and that's its sole purpose. So no one gets onto this server right here and uses it as a desktop machine. No, instead it's just a server that's handing out different services to these different clients, and perhaps it's to machines that are on the same network. So this could be like a DHCP server and a DNS server that's handing out services to clients that are on that same network right there. Or perhaps it's a remote network that it's administering these same services. So there are times when a DHCP server or a DNS server is actually on a separate network, and these machines right here have to reach out to this server in order to get some sort of services from that server. It's definitely the case, or I say most often the case, when you have like a web server that's hosting out HTTP, then there's a good chance that that's probably on a separate network other than your traditional client machines or your LANs that have your users that are actually accessing those servers. So what are some different protocols that exist on this application layer? Well, here's a big long list of them. And you probably recognize a lot of these from when we were talking about the ports, because there are a lot of ports that are associated with these different applications. But as we can see here, there's a lot of different applications for like file transfers, which would be the first couple examples here, few examples. Mail, which would be the next few examples here. And you're probably very familiar with HTTP and HTTPS as with web services, DNS for name resolution, the Telnet and SSH for remoting into machines, RDP for remoting into machines, DHCP, which we're going to talk a little more in depth here in a second about, network time protocol. So there's a lot of different protocols here that exist at this layer and really, facilitate or help users be able to access a lot of different resources. So let's get into some of those different applications and see what they do. All right, first up is DHCP. And the reason why I chose DHCP first is because really it's probably the first service that your computer is accessing when it starts up. And the reason for that is there are several things that we need on a computer for it to access the rest of the network. So we do need an IP address, we need a subnet mask, and those two things will give it access to the local area network. We also need a gateway for it to access the rest of the world, and we probably are going to use DNS, and so that way we can access a lot of different resources by name rather than IP address. So there's some things that your computer need in order to connect to the network. So in enters Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol gives this information to the computer. And so when a computer connects to the network, somehow it's going to need to get this information. We could statically assign this to the machine. And what that would allow us to do is to specify this machine has this IP address, it needs to get to this default gateway to get to the outside world, and it has this as a DNS server. We could statically assign that to that machine. But the problem is anytime we take that machine to another network and connect it into there, then we would have to manually go and reset all of that and make sure that we don't have an IP address that's already been handed out. And so in order for us to be more portable and take things around and be able to really manage these machines much easier, we set up DHCP, or Dynamic Host Configuration Protocol. That way, when we connect a laptop into this network right here, then it's going to be assigned an address to that network. It's going to be assigned an IP address and a subnet mask and a gateway that's relevant to this local area network. And then when we move it to another network, then it will be assigned according to whatever network that we connected into, provided that they have a DHCP server. So in this example right here, let's say our DHCP server is this 10.40.40.5. This machine connects into the network. It says, hey, I need this information because it has a DHCP client on this laptop right here. And this is a DHCP server, and says, since I'm a DHCP server, I'm going to give you an IP address and also let you know what the subnet mask is, gateway, and DNS for this local area network right here. Then when I move over to here, let's say that the 172.16.43.4 is then the DHCP server over here, and then it would hand out that information for this local area network over here. All right, the next application layer protocol that we're going to be talking about is going to be DNS. But before we do that, I'm going to talk about URLs. URL is not a protocol. URL is a way to identify resources that are out there. And so there's some specific ways that we configure URLs and what they look like. And so an example of a partial URL is www.technosurge.com. We're going to get more into URLs and what the full URL is. We're also going to compare what a URL is compared to a URI. So we're going to get into all of those details, but not quite yet. That's going to be another video. So for the purpose of this, a URL just identifies, a URL is a Uniform Resource Locator, and it identifies the resource that we're trying to get to by name. So an example is this www.technosurge.com. We typically, when a user is typing in to a machine, doesn't type in an IP address unless you're like a system administrator or network administrator, network engineer. Usually most users are typing in names of resources rather than IP addresses to get to those resources. So somehow we have to translate those URLs that users are typing into their application so they can get to a resource. So instead of that URL, the machine is going to get to that location using an IP address. So somehow it needs to translate from the URL to an IP address, and it does that through the domain name system. The domain name system allows us a mechanism to translate these URLs into IP addresses, so that way we can get to that resource. There's also a lot of other features that come into it. It's not just translating names into IP addresses. There's a few other lookups that it does to get what the location of these resources are. So we're going to talk more about DNS and fill out all of the information about DNS, or not all the information, but a lot of information in videos to come. But for the purpose of this, we're just going to say that the domain name system allows us to translate from a URL to an IP address, so from a URL to an IP address, so that way when we send packets asking for certain resources, we know where to send that. And then, of course, when the DNS is used in a lot of different scenarios to get a lot of different resources for a lot of different protocols. But one of the really common ones is HTTP and HTTPS. And that allows that machine to go to these different servers that are out there, and then get web pages and do a lot of other functionalities. HTTP and HTTPS actually is quite capable of doing a lot of different things, but it essentially is to go and get these resources on the web, so that way we can get those resources back to our machine. And it uses protocols such as HTTP, Hypertext Transfer Protocol, and HTTPS, which is Hypertext Transfer Protocol Secure, or HTTPS could be HTTP over SSL. We'll talk about some of the differences of that as well in later videos, but for now, HTTP is just a protocol that allows the transfer of this information back and forth, or allows the transfer of HTML pages back and forth, or allows the transfer of different pages, pictures, and other resources back and forth between a server and a client machine. Another very popular service out there is obviously email, used to send messages and files back and forth. Email services that's not a protocol in itself, but there are multiple protocols that allows this to happen. So one example of that is Simple Mail Transfer Protocol, which allows us to send mail. SMTP sends mail. And so you have a user here that wants to send mail to another user, and that user may or may not be online. And so this user might be offline at the time that you send it, so there needs to be some sort of asynchronous communication that happens back and forth, which means that it's not necessarily happening all in real time, and that user's not going to get it right away. They could get it the next time that they get online. And so there's that is one of the reasons why there's multiple protocols that are set up with this. But a user will send mail using SMTP, and it will go to a server. And then from that server will have to look up and say, hey, where is that email going to go to? Because it's going out to some other domain or some other resource that's out there. And so it has to do a lookup and figure out what server it needs to send that to. And then it will send that message to that server once again through SMTP. So there's SMTP is really the primary way that it's going to send this information out. And there's a couple protocols that also operate just like SMTP, but are in a secure manner. And then we need some sort of way that when this user comes back online, how is it going to get that information or download it onto that user's machine or onto that phone? And so there's a couple different types of connections. POP version 3 is one of those, or perhaps it makes an IMAP connection, and there's advantages and disadvantages to those two protocols. I would say that IMAP is the more popular of the two at this point. And so these users then will turn on their machine, turn on their email client, and then that email client will go and fetch or grab that information and pull it down to the user. So then the user has access to that email. All right, so there's some application layer basics. We talked about the OSI model and the TCP IP model, the differences between the two, and how a lot of the protocols you're going to be dealing with nowadays are really going to fall into the TCP IP model, which is why we combined those three different layers of the traditional OSI model into one application layer of the TCP IP model. We also talked about the difference between peer-to-peer, and that is users' machines sharing out resources together, versus client-server, where we have more of a server that's dedicated on a network that's serving out services to your different clients. Then we talked about some different application layer protocols. I gave you a list of different application layer protocols. There's really, that's just a tip of the iceberg. There's so many different ones out there. But we also talked about some specific ones such as DHCP, DNS, HTTP, HTTPS, and even some email protocols that we have out there. We also talked about URLs and that Uniform Resource Locator and how it could be used. And so we're going to go more in depth into this into some following videos now. Hope this video is helping you out. Can you help me out by hitting that like button?